Hello, everyone. There's several attendees already. I would like to thank you all for joining our webinar. My name is Raquel, and I'm the president of the NUIG Student Branch of ASHRAE. And today's topic is the demand response programs for building energy efficiency and users' comfort. So first, I'd like to welcome you all. This is the first official event of our student branch, and we're very happy you're here to attend. Our agenda for today, so I'll start with me, a welcoming introduction, and then we'll have three speakers. First, Dr. Marcus Keane in integrating demand response in energy management systems, and then María Luisa Serrano in respond and react projects in residential and community buildings. And at last, Toke Christensen with living with PV panels, household time shifting daily practices to optimize consumption of own PV power. So after the three presentations, we'll have a 15-minute Q&A session, and you can start posing your questions during the webinar, and then they will be answered in the Q&A session. And at the end, I'll just make some final comments about the webinar. So the first speaker will be Dr. Marcus Keane in integrating demand response in energy management systems. So he talked about an overview of European H2020 demand response research projects from 2017 and 2020 with a specific focus on the H2020 RESPOND and REACT projects. And Dr. Marcus Keane is the founder of the Informatics Research Unit for Sustainable Engineers, IRUS, and he's a lecturer at NUI Galway. He has extensive knowledge and experience in the development of integrated building information modeling, BIM, and to support holistic environmental and energy management in building and industrial processes. After him, María Luisa represents Respond and React projects in residential and community buildings. And in her presentation, she'll talk about the electricity systems need significantly evolving and constantly influencing the European utility industry. So distributed generation and renewable energies are gaining importance in most markets, leading to necessary grid adaptation. Several projects that receive funding from the EU are focused on DR solutions in domestic environment as Project Respond and Project React. And about the speaker, María Luisa Serrano is an electromechanical engineer of Universidad Pontificia de Comillas, Madrid, and holds a double master degree in industrial engineering and engineering for mobility and safety from the same university. She has experience in R&D and is currently with the Innovation and Regulation Department of the Spanish utility FENI Energía. The third speaker will be Toke, and he'll talk about living with PV panels, household time shifting daily practices to optimize consumption of own PV power. So in many countries, a rising number of homes get PV panels installed and becomes prosumers. This presentation focuses on how this affects the everyday practice of households with regard to time shifting their electricity consumption in order to optimize self-sufficiency. Results from Respond trial with homeowners and tenants are presented and compared. And about the speakers, Toke Christensen is a senior researcher at the Department of Built Environment at Aalborg University in Denmark. He has specialized in studies on user engagement and energy consumption related to smart energy technologies in the home. So during the presentations, you can pose questions using the question tab to ask any questions related to the presentation. So if you want to pose like during some specific presentation, you're free to ask. And you may also use the chat function. If you're having difficulty, you can send your queries to these two email addresses. And also at the handout section, you have the presentation material, so you can download to your PC. And if you would please, after the webinar, answer a very short survey, so just to improve our next webinars. And we're very happy to receive our speakers now. And your audio should be muted from during all the presentations. So if you have any questions, just use the question tab. So first, we'll start with Dr. Marcus Keane. Thank you very much, Marcus, for joining us today. If you'd like to start your presentation. I'll just switch off my camera now.
Okay, thank you very much, Raquel. My name is Marcus Keane. I'm a lecturer in Civil and Energy Systems Engineering at NUI Galway. And I just want to basically give a background to the kind of research that has been done under energy efficiency 2016-2017, which focuses mainly on secure, clean, and efficient energy. So this particular program has been broken down into a number of different focus areas. These include heating and cooling, that runs through EE 1 through to 5, engaging consumers towards sustainable energy. That includes EE 6 to 9, and buildings that we will talk about today, which is EE 10 through to 14, and industry services and products, EE 15 through to 21, and innovative financing and energy efficient investments, which are energy EE 22 to 25. So these are all different thematic focus areas that the European Union has focused on under the H2020 EE 2016-2017. Now I've highlighted buildings because the RESPOND and REACT projects come under EE 12. Okay, so I need to go to the next slide, Raquel. I don't seem to have control. Thank you. Okay, so what I've done here is I'm specifically showing you the projects that were actually funded under EE 12, and these are innovation actions. All right, so the reason I wanted to do that is to show you exactly what the focus of EE 12 was or is in this instance. So it's focusing on integrating demand response into the energy management systems while still ensuring interoperability through public and private partnerships. So you'll see in terms of the icons on the right, there were 4 specific projects funded under EE 12. TABED, DRIMPAC, Holsitter, and our project that we will be talking about, Louisa in particular will talk about, RESPOND. And just to give you a sense of the scale of the investment from the European Union in those projects, they mostly ranged in the financial cost of about 3.5, 3.6 million. Hollister was larger, and as a number of projects together, they totaled over 15.6 million. Okay, so let me just give you some kind of feel for the projects themselves. So Raquel, if you can go to the next slide, please. Okay, so what I want to show on each one of these slides is primarily the general objective of each project, the constituent countries and partners, and the expertise that are involved, because all of the projects are essentially trying to leverage existing energy management systems and developing new and novel software platforms that enable demand response programs to be implemented across usually 3 pilot sites. So TABED allows all buildings to integrate energy grid demand response through low-cost extender for BMS systems. Now, these low-cost extenders are essentially software platforms, and these software platforms have to be independent of both the COM standards, and they have to be able to integrate flexible algorithms. And you can see the profile there, anywhere from the UK countries to the Netherlands. You have France, Italy, and Switzerland with all various different types of expertise, from academic with Cardiff, Schneider, BM Building Management Systems, CSM, innovative developers of algorithms to do with control, as is NG as well. R2M are research to market. They provide energy services, and also they provide dissemination activities for taking research outputs and bringing them to the market. Okay, so the pilots, next slide please. The pilots, as you can see in this case, were a mixed number of buildings in France, the UK, and in Bergamo in Italy. So in terms of the French pilot, it's an industrial campus. The UK pilot in Cardiff in Wales is residential building, and again in Bergamo, Italy, it's a smart house. So again, you're getting a sense of the type of building. So this concept around using different types of buildings for different testing of the different platforms. So the next one, please. Okay, Alistair, I'll move quickly. Again, it's a very, very similar framework. You can see the mix of partners there, etc. And again, what they're trying to do is develop a hardware-software platform. Next slide, please. Okay. And again, we have different buildings in this particular in terms of pilots, and you can see that in this case, the vast majority are industrial scale buildings that include apartment blocks, office space, etc. Next slide, please. DRIMPAC, I couldn't get as much information on, but you can see the partner spread, and the pilot in this case, next slide, please, is the university in Cyprus. So again, they were trying to test how they would actually integrate different building management systems, IT systems, draw the data through and use them for demand response programs. And finally, last but not least, next slide, please, is RESPOND. And this is what María Luisa will discuss today, as well as the actual REACT. And again, you can see RESPOND, we have a mix of different countries. In the Aran Islands, sorry, in Ireland, we have the Aran Islands, which is Cor Common Gwynedd, which is basically the energy co-op in Irish, our own university, NUI Galway. And down in Spain, we have Techniker, Dexma, and Fenia, that María Luisa is from. And we have up in Denmark, we have the University of Aalborg in Copenhagen. So Toke will talk on their behalf, and various technology companies from Denmark and from the Czech Republic, and also the Institute Michalo Pupin. Next slide, please. So the focus with the RESPOND, as you can see here, is a mixed use. So we're looking at dwellings on the Aran Islands, top right. We're talking about social housing in the middle from Aarhus in Denmark. And the bottom, we're talking about an apartment complex in Madrid in Spain. Okay, next slide. Okay, so I'm just giving you a taste for the actual focus of EE12. And now I'm going to hand over to María Luisa to actually give you some more detail as regards the actual RESPOND and REACT projects. Thank you very much.
Thank you very much, Dr. Marcus. Now we go to the next presentation from María Luisa. If you want to take over.
Yes, so thank you, Raquel. Thank you everyone for coming, well, or for attending to this webinar. This is María Luisa speaking. Sorry that I'm not turning my camera on, but I'm having some connectivity issues today. So as they have been saying, I'm going to introduce projects RESPOND and REACT oriented to the residential sector. So as you may know, this sector is being very influenced by the evolving of the electricity system. So actually one of the main, yeah, I can change. Okay, so one of the main motivation for this is that distributed generation and renewable energies are gaining a lot of importance in most markets, which leads to a necessary grid adaptation. So demand response, among other solutions, facilitates their integration into the grid. There are several European projects. I can't change anymore, Raquel. Sorry for that. That are focused on DR solutions for the domestic environment, as Marcus has been introducing. So actually demand response has existed for many years now. It's been called by different names as load management, but it is indeed any reaction to a stimulus that changes electricity demand in a market. So for the past 5 decades, it has evolved dramatically as new business models are arising. So commonly it's been implemented in the industrial sector. The reason for this is that the energy use is very high in it. So peak energy demand means a significant cost to utilities and to the grid. However, DR programs are starting to play a very important role in balancing energy demand in the domestic sector as well. So new figures are arising, including active consumers, independent aggregators, citizen energy communities, VPPs or V2G technology. And they facilitate domestic users' active participation in the electricity markets so they can manage their energy consumption, their generation and storage. But with the COVID-19 pandemic, moreover, they spend more time home, so they are accelerating this paradigm shift. However, in this regard, not only technical aspects should be considered, but electricity markets legislation should be very adapted. So the EU Directive 2019-944 already defines some key terms in this regard. such as demand response and demand aggregation, and actors like I've been talking about, the active consumers, independent aggregators, and citizen energy communities. So how do actually project Respond and React contribute to this process? So in the first side, Respond is a 3-year project that started in 2017. It's very close to its end. And it stands for Integrated Demand Response Solution Towards Energy Positive Neighborhoods, as you can read on screen. So its main objective, indeed, is to adapt demand response so that domestic consumers can benefit from it. So it implements a cooperative energy demand management solution for the residential sector so that the users can better match energy supply with demand. For such purpose, it deploys an interoperable energy automation, monitoring, and control solution that delivers demand response at building unit, building, and district level. So it uses smart energy monitoring, and it's able to detect energy conservation opportunities and adapt indoor and outdoor conditions, as well as comfort levels in real time. So by participating in demand response programs, what do domestic users gain? So not only economic benefits are achieved, but they do gain a deep knowledge on how electricity markets work, thanks to being an active participant of them. So on the one hand, it has been estimated that, can't change anymore, sorry. There, sorry. So on the one hand, it has been estimated that when operating in the Spanish electricity market, users can reduce 4% of their bills just by reallocating their energy consumption. But moreover, feedback from utilities help them be aware of their consumption, and they try to save energy as a consequence. So several studies have shown that this feedback can help them save up to 7% of their energy. So apart from contributing to grid stability, which is a key aspect for demand response, these energy savings actually help reduce greenhouse emissions and increase Europeans' overall energy efficiency. But to complement this, not only a theoretical analysis was developed, but the response solution was deployed in 3 pilot sites. They are at different geographical locations in different climate zones and located in cities with different population densities. Moreover, they have different underlying energy systems and different types of ownership, both rental and home owners. So the first pilot site is located in the Aran Islands of Ireland. It is composed by single-family homes with PV panels grouped in an energy cooperative. The second pilot is in Aarhus, Denmark. It is a social housing managed by a non-profit entity, and it also has PV panels. And the final pilot is located in Madrid, in Spain. It is a neighborhood community of several multi-height buildings, and it has solar thermal panels in this case. So Fenia Energia was the utility that managed the Madrid pilot site. So I can tell you a bit more about our findings. So we measured electricity consumption in the different dwellings, and we analyzed how users respond to the price signals or incentive we send them. For this, they count with an app where they could see the real-time consumption, and they received these notifications about happy hours. In these happy hours, the energy was cheap or very cheap or free. So we defined 3 different incentive periods. The first one was of up to 14 hours a day. The second one was shortened to 1 or 2 hours a day. And in the third one, actually, we paid them through incentives to reduce their consumption at certain times. So what we observed from the results and interviews is that price incentives do have a good impact on time shifting consumption. Thanks to these, that households were able to see their hourly consumption, they got familiarized with how much energy their appliances consume. Thanks to these, they tried to reduce the use of some non-essential appliances when they saw their high consumption, such as the tumble dryer. And all in all, they were able to adapt the use of several appliances. The ones they time shifted most were washing machines, tumble dryers, or dishwashers. And this was actually facilitated by the time programming function that many of them incorporate into their operation. So some users also told us that they shifted the use of induction cookers and kitchen robots if they were able to leave the meals prepared beforehand. So it was actually measured that during the third period of incentives, the users of the Madrid pilot reallocated an average of more than 8% of their consumption. to non-peak hours, which is a very positive result. However, this result can be in some way biased by COVID-19 because on the one hand, it has facilitated a higher flexibility in the household schedules because people spend more time at home, which is motivated in part by the new possibilities of home office. And on the other hand, spending more time at home also means that in many cases, the consumption increases. Okay, so I hope this gives a clear insight of Project RESPOND, and now I will introduce Project REACT. So it's been going on for less time. It's a 4-year project that started in 2019. It stands for Renewable Energy for Self-Sustainable Island Communities. And the reason is that most islands are connected to a bigger island or to the peninsula in case of Spain with the Balearic Islands via a submarine cable. So they are highly dependent on it. So the objective of this project is to achieve island energy independency by joining renewable energy sources and storage with a demand response platform. So REACT will develop a technical and business model to demonstrate that these technologies can bring important economic benefits and contribute to the decarbonization of local energy systems, reduce greenhouse gas emissions, and improve environmental air quality. This project, moreover, will also contribute to promoting user engagement in local energy communities. So REACT will follow a threefold approach, which is driven by users, sustainable energy, and technology. Firstly, on the user's point of view, the aim is to motivate and engage the island communities to be an active part in the control loop when they manually influence the energy demand curve. So via this engagement, REACT will be able to exploit the demand flexibility and to match the energy demand with the renewables generation and buffered energy that can then be released in peak demand periods. So from the sustainable energy point of view, REACT will bring energy savings, carbon emissions, and energy cost reduction, which are leveraged by an integrative approach to multi-carrier supply and demand-side optimization, contributed by a higher renewables penetration, which is combined with a cooperative demand response strategy. And finally, about the technology, a scalable ICT platform enables a digitalized smart grid that is based on distributed generation and demand response. It follows a user-centered design, which helps deliver a solution that is easy to use and has added value for the users. So on screen now, you can see a visual infographic about the project's technology and the benefits it will bring to the islands. So energy generation as well as storage will be deployed in them, as well as its planning and management, of course. So nowadays, currently, the solution is being implemented in 3 different pilot sites. There are 3 different islands that have similar size, but different climate zones, energy requirements, and population. So the first of them is La Graciosa. It is located in the Canary Islands of Spain. Secondly, there is San Pietro in the island of Sardinia in Italy, and then the Aran Islands again of Ireland. So Fenia Energía is the pilot case coordinator of La Graciosa site, and I can tell you a bit about the status of these pilot sites. We have gathered around 20 participants already and have developed in collaboration with other companies the corresponding engineering projects for the installation and the deployment of about 60 kilowatt peak of PV panels for these participants. Apart from these PV panels, of course, some of them include energy accumulation, meaning batteries. And the objective of all these is to create an energy community, and that this energy community is as little dependent as possible on Lanzarote Island, to which La Graciosa is connected by a 1,030 kilowatt submarine cable. And what to say, up until now, La Graciosa inhabitants have shown a very positive attitude towards the project and towards renewables integration. So let's hope to maintain it along the whole project. So I hope you enjoyed these 2 introductions and overviews. Now I leave the word to my colleague, Toke.
Thank you very much, María Luisa. Now we're heading to our last presentation of the day. So Toke.
Thank you very much.
If you want to share.
Yes, and thank you, Maria. Well, so I can change slides as well now. So, okay, perfect. So thank you. I'm going to tell about some of the results from a trial we did in the RESPOND project, as Maria and Marcus told about previously. So well, I changed slide here, hopefully. Yes, it works. Perfect. So what we looked at in this trial was to increase auto-consumption of self-sufficiency, you might also call it, in households with rooftop PVs. Well, you know, this microgeneration has become more and more prevalent, or not prevalent at least, but it has become more widespread in recent years with lower prices on PV panels, and therefore more and more households install PVs and therefore also become prosumers. It's a term that has been invented some years ago, combining consumer and producer into prosumers. So, and what research has shown until now is that maybe, or it seems to be that if you get your own power station somehow on your rooftop, it also is something that engages people in their own electricity consumption and time shifting of consumption, so they can increase their auto consumption. So in RESPOND, we looked into this in the 2 of the pilot sites on Aran Islands and in Aarhus in Denmark. It included also trying out how would, with an app, how would app notifications be offered the participants in these trials to download an app, and how could this getting access to the app and notifications, how could that help people? So thanks for shifting a slide. Yes, so I think I'll go back just one. I think we went maybe one slide back again. Yeah, perfect. Thank you. Yeah, it's the next one. The next one, please. Yes, thank you. So in Aarhus we have social housing. It's an urban. So we have these 2 pilot sites, and they are quite different as context for the trials. In Aarhus we have a social housing community, and on Aran Islands we have owner-occupied dwellings. So it's two quite different places. In Aarhus, the PV panels they are installed on the roofs of the buildings, but they are collectively owned. So it's actually the tenants is part of the association and they own it collectively. Whereas on Aran Islands, it's owner-occupied dwellings, so people own their own PV panels. So that's also a difference to have in mind. So please, I think the next slide. So, oh, thank you very much. So yeah, so at both sides we provided the participants, the participating households, with this app, which could be downloaded on the mobile phone, and through this app we issued a number of notifications to people. In Aarhus, it was a daily notification telling the household that next day you could time shift your consumption to a specific set of hours, and then you would increase the auto consumption. And on Aran Islands, we also did this with notifications, but fewer notifications. So it was not daily notifications, but more irregular notification. In both cases, the notifications were based on weather predictions. So in order to see when would the production of PV power peak during the next day. And so we had this trial running from May to August this year. So next, please. So yes, here this slide does show on the left hand you can see the notifications the households in Aarhus would receive, and you can't read it because it's in Danish, but it tells basically that it recommends people to shift consumption, in this case to between 1 and 3 p.m. and it also says something like, then if you shift dishwashing or laundering, then you would save electricity because you use your own electricity, and it would be good for the economy of the housing association. Another thing we also did was, as you could see on the right side, that we also had a possibility for the households in Aarhus to compare the level of PV power production in their own electricity consumption with the neighbors. So what we did was that we evaluated the user engagement through qualitative interviews, which were done by Skype or phone because of COVID-19. And if you go to the next slide, please. Yes, here are some of the main results from the 2 pilot sites. First, we can see in the case of Aarhus we actually did have a limited time shifting, whereas on the Aran Islands, the households taking part in this and having PVs, they did quite a lot of time shifting. They time shifted dishwashing and also doing the laundry. So that kind of activities were time shifted. What we discovered was that one of the reasons for the difference is certainly that for the Aran Islands households, they had a very direct incentive to time shift consumption, because they wouldn't earn any money from selling the excess power to the grid. So therefore, if they could time shift consumption from night hours or evening hours to daylight hours, then they would save the money instead of buying it from a grid. So they had a very strong financial incentive, which played out a big role for this in comparing these two sides. And so another thing we also learned from the Aran Islands household was that they didn't actually use the app notifications that much. And the reason for this was that they already before the trial had established routines of time shifting consumptions, because they have had these PV panels for many years in some cases, and therefore they already before the trial had established these routines. So, and therefore what they had learned was basically to watch the weather, see if the sun was shining, maybe looking at the weather report the day before, and then they would adapt on a day-to-day basis. But that's different in Aarhus, and there we saw actually some effect, even though the Aarhus households didn't time shift much due to the lack of financial incentive. They actually told stories about how the notifications which they received in the evening before the next day had an impact on the decision about, for instance, postponing dishwashing to the next day. So one of the key learnings from this is that tools like this app can be an important way of learning people who wants to change their practices, who wants to learn how to time shift their consumption. But if you already time shifted it, maybe it doesn't have the same kind of impact on people's behavior. So the final slide, please. Yes, so moving to the conclusions. So we learned, as I said, that establishing new routines of time shifting is definitely possible. So active time shifting is possible. We saw this on the Aran Islands. They were quite enthusiastic actually about time shifting consumption, most of the households. But app notifications might have a special niche use, where you have a target group of people who want to time shift their consumption, learn new practices, but haven't done it yet. So it can be a tool of learning in a way. And of course, we also learned that financial incentives are very important for the engagement in time shifting. And finally, which is also a bit of an open question perhaps, but we also saw this difference between social housing and owner-occupied dwellings. Both had PV panels, but of course, in the social housing situation, it's not like owning your own PV panel, but it's more like the organization you are part of is owning this PV panel. So therefore, it might not have the same kind of engagement element to it as it would have had if it was owner occupied. So, but that's something we need to take into consideration also, I think, in the future. So these were the words from me. So thank you for the attention.
Thank you very much, Tauke, for your presentation. And yeah, thank you for attending. And now we're heading to the Q&A sessions. We have already some questions here that I'm going to pose to the speakers, and they can ask the questions. So just let me get here. So the first question is, what are the typically experienced challenges and barriers in implementing demand response programs?
Yes, I can answer that. Let's see if I can turn my camera on. I don't know how that's gonna work. Can you hear me all right?
Yeah.
Perfect.
I can hear you.
So I would say that one of the main challenges would be regulation issues, meaning legal issues and all that stuff, because many countries don't yet have the legislations adapted so that demand response can be actually implemented for the domestic sector, meaning with the level of benefits, with how much power they can enter the market and all that. But also talking about the pilots, about the user engagement. So one issue was the age. There are some participants that actually don't use their phones so much, so they didn't get to see the notifications, or they wouldn't get into the app. So some users would prefer text messages instead of notifications, or even phone calls. Other issue would be that maybe sometimes people want to commit, but then when the time comes, they can't actually, well, as I was saying, change the cooking time or several issues like that. So I'd say those were the main issues in level of a pilot, in a pilot level. Yeah, the participants. I don't know if anyone wants to add something, or that answered the question.
I wouldn't mind just to add that I think certainly in the case of the Aran Islands, I think as Toke mentioned, these are owner-occupied residences. So it's very important in terms of how, sort of what expectations are raised within the residences as to what energy savings may be achieved, and particularly when you're talking about different types of retrofits, so that the particular houses can engage in demand response. So for example, if you have deep retrofits that might include insulation, heat pump installation, PV panels, etc., it's very important that the owners of the houses, which could come from various demographics, so you could have single occupant of a certain age, or you could have family, or you could have, you know, a couple, or whatever else it might be, just so that it's very clearly explained to them what they can expect in terms of energy savings. So for example, going from oil to electricity, so that they understand that your electricity bills will go up even though your oil will go down, so that they don't think because you're getting renewable energy that everything is free. It's just that you're mixing your fuel sources, etc. So I think very much the social side, and the other side is the expectation from technology. So I think we have to be very careful as regards the quality of the data that can be delivered through the different sensors and meters and databases, etc. And you know how often those particular situations have to be evaluated. And as María Luisa said, definitely the regulatory side of things, because in the terms of the Aran Islands houses, basically you cannot sell your electricity at the moment as a prosumer, as Toki referred to. It basically spills. If you don't use the electricity coming from your panels, it just goes back onto the grid and you get nothing for it at the moment. Now, when the actual smart meter rollout occurs, etc., hopefully in Ireland, we will be able to change that situation. Okay.
Yes, and if I might add to the other answers, I think I'm completely agree with both Maria and Marcus on what they said. And I think from a user perspective, it's very important to create solutions that are easy to understand for people, also schemes easy to grasp for people, and because often it is in situation often that these schemes are developed by engineers, and I'm basically an engineer myself. So, but it's often people who have a very technical mindset, but it doesn't necessarily fit with what people think and understand in households and people in general. And another thing I think is very important is also to develop solutions that will not be changed too often. Because what we also learned from the RESPOND project is that if you change the scheme, for instance, the time of use tariff scheme, too often people get confused because they tend to, they learn, okay, here's something new, I have to learn it. Okay, I'm happy, I'm trying to learn it, it's good. But then half a year later, if people say, oh, but you have to do it in another way, actually, people get a bit reluctant because they find it's both cognitive and also it takes some efforts for people to learn new practices, and they don't like to do it too often, I think. So it's also important to create schemes and solutions that will work for long. So yes.
Yeah, I totally agree with you, Toke. That happened in the Madrid pilot actually when we changed the time periods I was talking about. So some users got a bit of trouble with adapting to the new period. So yeah, I know what you mean.
Exactly. So thank you. So.
I can respond to Ricardo's question if that makes a bit of sense. And again, I'll start to use the Aaron pilot, and this specifically relates to my colleague Diane, who did an awful lot of this work specifically to do with data granularity, and my colleague Federico Seri. So data granularity depends very much on the actual technology systems that you install in terms of the different sensors and meters. So it can be literally to the second, it can be to the minute, it can be to the quarter hour, and it can be to the hour. It depends on what it's going to be used for in the end. And specifically, Diane found out and developed essentially within RESPOND a key performance metric to do with data quality, which we hadn't anticipated originally. In other words, we wanted to be sure against all of the different pilots, including Aarhus and Madrid, that the data that we were getting was of a sufficient quality so that we could make certain decisions and notifications to the users. So in a technical sense, which comes onto the software, our different partners from Serbia, so INP, and from Spain, Techniker, etc., they were providing prediction as regards the possible production of solar energy in one case, which was the Pukin guys. And in terms of the demand profiles, the Techniker people were figuring out what they would be based on climate, etc. But again, it depends on the accuracy of the weather stations that you're taking this information from, and depends on the accuracy of the benchmark that you would have done previously based on the user profile. So in terms of energy modeling, we did a number of different types. We did what we call whole building energy simulation modeling. So we had colleagues, Connor Dean, who finished his master's. He submitted his master's, we've almost finished it, where he was doing whole building energy simulation using a tool called IES, Integrated Environmental Solutions. And then another colleague, Alessandro Piccinini, basically took the outputs from that and was able to develop it as what we call reduced order models, so we could run it in real time against the data sets. So the granularity depends on what you want to do. So when we get the predictions and then we take the data from the measurements, then we're able to compare both of them to see how much they've actually caused an impact as described by Tokyo. So in other words, in the Aran Islands in particular, we were able to try and push a shift in the actual demand, whereby they could use the solar PV generated electricity as much as possible. So I don't know, that's a long story short, but there you go. Okay, just a quick response to Sean there. Sean is a colleague as well. The shifting part was not automated, okay?